this video, we are going to talk about combinatorics. Combinatorics is concerned with permutations and then combinations. Permutation is concerned with arrangement of objects, and then combinations is concerned with selecting objects. So let's talk about permutations. For example, let's say we have this word RCOONA. What is this? This is sodium alkanoate. Sodium alkanoate is an organic molecule. Now, let's say we rearrange starting from C. So if we start from C, then O, R, and O, then NA. You see that now the word has changed. First, it was sodium alkanoate. However, this is corona. So this is a virus, and this is an organic molecule. So you see that by just changing the position of the letters, we form different meaning out of the existing word. So it means that the arrangement matters in this case. However, if this was combination, then sodium alkanoate and corona is the same thing. It doesn't matter the way we arrange the letters. Since the letters are the same, then it is the same in terms of combinations. Now, let's talk about, for example, let's consider the word BAT. BAT is bat. A bat is an animal. Let's rearrange starting from the back. TAB. TAB is what? Tab. The tab key is a computer key. So tab is a computer key. So this is in computer, whereas this is an animal. So you see that in just rearrangement, we have changed the meaning of the word. So the arrangement matters in this case as well. So in how many ways can we arrange the word hot if we are to take two letters at a time? So let's take first HO, and then the second one HT, and the third one is OT. We can also reverse by taking OH, then TH, and then TO. So in how many ways can we arrange this word HOT? 1, 2, 3, 4, 5, 6. So there are 6 ways. That is in terms of permutations. But in terms of combination, HO and OH is the same. HT and TH is also the same. And OT and TO is also the same. So in terms of combinations, there are only 3 ways of arranging the word hot, taking 2 at a time. In how many ways can we arrange the word physical? Now, let's count the number of letters that makes up the word physical, which is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters. Now, let's see if there are any repetitions of the letters. Physical is made up of 8 different letters, and therefore, the number of ways to arrange 8 different letters when there are no repetition is, so the number of ways is equal to 8 factorial, and then 8 factorial is equal to 40,320 different ways. What if we were given the word straw, STRAW? In how many ways can we arrange the word straw? So let's count the number of letters. 1, 2, 3, 4, 5. Straw is made up of 5 letters. Then the next thing to check is whether there are any repetitions. There are no repetitions of letters, and therefore the number of ways is equal to 5 factorial. And then 5 factorial is equal to 120 ways. Now, the way of solving n factorial is, so n factorial is equal to n times n minus 1 factorial, or it can also be equal to n times n minus 1 times n minus 2 factorial. So you keep subtracting 1 from the n factorial till you get 0 factorial, which is equal to 1. So for example, if we say 4 factorial, what is 4 factorial? 4 factorial is equal to 4 times 3 times 2 times 1, then times 0 factorial. But 0 factorial is 1. So at the end of the day, it becomes 4 times 3, which is 12. 12 times 2 is 24. 24 times 1 is 24. Times 0 factorial is still 24. So 4 factorial is equal to 24. Let's say 5 factorial. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Then 0 factorial is 1. So this is equal to 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. And therefore 5 factorial is 120. So what if we are given the word carrot to arrange? In how many ways can we arrange the word carrot? Now, how many letters makes up carrot? 1, 2, 3, 4, 5, 6. So there are 6 letters. However, for carrot, there's repetition. The R repeats twice, so repetition. There are 2 repetitions, and therefore, the number of ways of arranging carrots is equal to 6 letters, so which is 6 factorial. Then we divide by the number of repetitions. So 2 repetitions, which is 2 factorial. And this is equal to 6 factorial is 6 times 5 times 4 times 3 times 2 factorial divided by 2 factorial. And then 2 factorial and this 2 factorial can cancel out. So we are left with 6 times 5, which is 30. 30 times 4 is 120. Then 120 times 3 is equal to 360. So there are 360 different ways of arranging the word carrot. Mathematically, to find the number of ways you can arrange objects, it is given as n permutation r. And the definition of n permutation r is n factorial divided by n minus r factorial. And the number of ways to select objects is given as n combination r. And mathematically, n combination r is defined as n factorial divided by n minus r factorial, r factorial. So you see that if you compare this to this, then we can say that n combination r is equal to n permutation r divided by r factorial. So these are 3 very important mathematical equations as far as combinatorics is concerned. So let's solve this question. Simplify 5n combination 2 divided by 5n permutation 2. So 5n combination 2 can be written as 5n factorial divided by 5n minus 2 factorial, then 2 factorial. Then this divided by 5n factorial, then divided by 5n minus 2 factorial. So let's remove this divided by and put sign times. So 5n factorial divided by 5n minus 2, 5n minus 2 factorial, 2 factorial, then times 5n minus 2 factorial divided by 5n factorial. So this 5n factorial and 5n factorial will cancel out. So at the end of the day, this is equal to 5n minus 2 factorial divided by 5n minus 2 factorial 2 factorial. So you see that this one too will cancel. 5n minus 2 factorial will cancel 5n minus 2 factorial. So this is, we are left with 1 divided by 2 factorial. And 2 factorial is the same as 2 times 1 times 0 factorial. Now 0 factorial is 1, so it becomes 2 times 1 times 1. And this is equal to 2. So therefore, 1 over 2 factorial is equal to 1 over 2. Given that n combination 4 divided by n permutation 2 is equal to 1 over 2, find the value of n. So let's write n combination 4 divided by n permutation 2 is equal to 1 over 2. So let's cross multiply. So this becomes 2 combination 4 is equal to 1 times n permutation 2. Now, what is 2 combination 4? Sorry. So this becomes 2 times n combination 4 equals n permutation 2. So let's express n combination 4. So this becomes 2 times n combination 4 is the same as n factorial divided by n minus 4 factorial 4 factorial equals n factorial divided by n minus 2 factorial. That is for n permutation 2. Now let's continue from this side. So I want to bring the n factorial down here and take n minus 4 factorial to this place. So it becomes 2 times n factorial divided by n factorial equals, then we take this one here, becomes n minus 4 factorial divided by n minus 2 factorial. So n factorial can cancel out. So we are left with 2 on this side. Then now let's express, so we will be left with n minus 4 factorial divided by n minus 2 factorial. Then this is equal to 2. So n minus 4 factorial divided by n minus 2 factorial can also be written as n minus 2, then times n minus 3, then times n minus 4 factorial equals 2. So n minus 4 factorial and n minus 4 factorial can cancel out. So at the end of the day, I'm taking n minus 2 factorial here and bringing 2 down here. So we'll be left with n minus 2 times n minus 3. Then this is equal to 4 factorial divided by 2. So let's expand here. So this becomes n squared. Then minus 2 times n is minus 2n. Then n times minus 3 is minus 3n. Then minus 2 times minus 3 becomes plus 6. Equals 4 factorial is the same as 4 times 3 times 2 factorial. And 2 factorial is the same as 2 times 1 divided by 2. So these 2 and these 2 can cancel out. 4 times 3 is 12, times 1 is still 12. So it becomes n squared. Then minus 2n minus 3n becomes minus 5n. Then plus 6 equals 12. You can shift this 12 here. So it becomes n squared minus 5n. Then 6 minus 12 becomes minus 6 equals 0. So two numbers that when we multiply, we'll get minus 6. But when we add, we'll get minus 5. So those numbers are minus 6 and 1. So it becomes n minus 6 in one bracket, then n plus 1 in another bracket equals 0. So the values of n are n equals 6 or n equals minus 1. However, n cannot be equal to minus 1 because in terms of combinations and permutations, n must always be greater than 0. And therefore the value of n is equal to 6 since n is greater than 0. So simplify n combination r divided by n combination r minus 1. So this is equal to n combination r is the same as n factorial divided by n minus r factorial, r factorial. Then this divided by n combination r minus 1 is n factorial divided by n minus. Now, here's r minus 1, so into bracket r minus 1 factorial. Then another bracket r minus 1 factorial. So let's change this sign to times. So this is equal to n factorial divided by n minus r factorial times into bracket n, then here becomes minus r plus 1 factorial r minus 1 factorial divided by n factorial. So at the end of the day, n factorial and n factorial can cancel out. So we are left with into bracket n minus r plus 1 factorial, then times r minus 1 factorial divided by n minus r factorial, r factorial. So now n minus r plus 1 factorial can also be written as n minus r plus 1. Then we'll subtract 1 from n minus r plus 1. So it becomes n minus r plus 1 minus 1, which becomes n minus r factorial. Then we're already having r minus 1 factorial. Then divided by n minus r factorial. However, r factorial can also be written as r times r minus 1 factorial. So at the end of the day, you can see that there's n minus r factorial here. There's this one here, so they can cancel out. And there's also r minus 1 factorial, r minus 1 factorial can also cancel out. So continuing from this side, we'll be left with n minus r plus 1 divided by r. So this becomes our final answer. So A, in how many ways can the letters of calculus be arranged in a straight line? So we have the word calculus. How many letters are that? 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. So there are 8 letters in calculus. However, you can see that C is repeated twice. And then L is also repeated twice. Then and then U is also repeated twice. So the total number of ways that we can arrange calculus is equal to 8 factorial because there are 8 letters in total divided by the number of repetitions. So 2 factorial times 2 factorial times 2 factorial. So this is equal to 8 factorial is the same as 8 times 7 factorial. Then 2 factorial is 2 times 2 factorial, which is 2 times 2 is 4, times another 2 is 8, so divided by 8. So at the end of the day, this 8 and this 8 can cancel out. So this is equal to 7 factorial, and 7 factorial is equal to 5,040 ways. So there are 5,040 ways of arranging calculus. Then this one says that find the total number of arrangements of any 3 letters of the word chemistry. So since it is arrangement, then we are talking about permutations. So chemistry, how many letters makes up chemistry? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 letters. So therefore, the total number of ways is, but he says that taking 3 letters at a time. So that is 9 permutation 3. And 9 permutation 3 is equal to 504 ways. In how many ways can 3 mathematics books, 4 history books, and 3 chemistry books be arranged so that all books of the same subject are together? So we have mathematics books, and there are 3. How many ways can we arrange 3 mathematics books? That is equal to 3 factorial. Then the number of history books, there are 4. And we can arrange that in 4 factorial different ways. Then the number of chemistry books are 3. And we can arrange that in 3 factorial ways. However, we have mathematics, history, and chemistry. And we can arrange all of this in 3 factorial different ways. That is taking mathematics, history, and then chemistry together. So the total number of ways is equal to 3 factorial times 4 factorial times 3 factorial, then times this 3 factorial. And this is equal to 10,368. In how many ways can a committee of 3 women and 2 men be selected from a group of 5 women and 7 men? So the committee is made up of 5 women. So the number of women is equal to 5. And then 7 men. So the number of men is equal to 7. However, we are supposed to select 3 women from 5 women and then 2 men from 7 men. So at the end of the day, it's going to be 5 combination 3, then times 7 combination 2. 5 combination 3 is 10 times 7 combination 2 is 21. So 10 times 21 is 210. So there are 210 different ways of doing that. A committee of 3 boys and 2 girls is to be formed from a group of 6 boys and 3 girls. In how many ways can this be done if one particular boy must be on the committee? So you can see that the number of boys, the total number of boys is 6 boys. And then the total number of girls is 3 girls. However, we are supposed to select 3 boys and then 2 girls. However, there must be 1 boy on the committee. So that means the one has already been selected. Then the next thing is that if we select 1 boy, then the total number of boys becomes 5. So the remaining 2 boys, because we must select 3 boys, must be selected from 5 boys. And that becomes 5 combination 2. Then times the number of ways of selecting 2 girls from 3 girls is 3 combination 2. And therefore this is equal to 1 times 5 combination 2 is 10. Then 3 combination 2 is 3. So 1 times 10 times 3 is equal to 30. So the number of ways are 30 ways.